Hello friends, today we are going to study about the Pitot Tube. Pitot Tube is basically used for measuring the flow of fluid at any point in a pipe or a channel. It is based on a principle that if the velocity of flow at a point becomes zero, then the pressure there is increased due to the conversion of the kinetic energy into pressure energy. So whatever the velocity will be at that particular point, it is converted into pressure energy, and which can be measured by the manometer, and it is reflected into this manometer. By using this we can measure the velocity. In its simplest form, the pitot tube consists of a glass tube, which we can see here. It consists of a glass tube bent at right angles. The angle between these two limbs is 90 degree, and it is shown in this figure. The lower end of this tube, which is bent at 90 degree, is directed in the upstream direction, means flow is flowing directly into this pitot tube. The liquid rises up in the tube due to conversion of kinetic energy into pressure energy. So whatever the energy this flowing fluid has due to its velocity, so it is converted into the pressure energy into this other limb, into this second limb. Okay. The velocity is determined by measuring the rise of the liquid into this tube. Hence the velocity is determined by measuring this rise. So whatever the height of this liquid, by measuring this we can measure the velocity into this tube. For this we have considered 2 points into this diagram. The point 1, which is in the upstream direction far away from this pitot tube, and point 2 is at the entry of the pitot tube. So at point 1 the pressure intensity, suppose it is P1, velocity is V1. Then at point 2 pressure intensity is P2, velocity is V2. Obviously if you need to measure the velocity and convert it into completely into the head, then the velocity should become 0. Means if the velocity is 0, then we can say that it is completely converted into the pressure energy. Hence the velocity at point 2 is 0. Then capital H is the depth of the tube in the liquid. So obviously we can see this is H. This is the depth of the pitot tube into the liquid. Means it is the static pressure. And P is equal to rho GH according to hydrostatic law. So whatever the liquid level of the free surface of the liquid from this pitot tube, it is measured as or called as capital H. And the small h is the rise of the liquid in the tube above the free surface. And the whatever the extra rise into this liquid into this pitot tube, it is called as small h, which is actually the conversion of kinetic energy into this pressure head. Now if we apply the Bernoulli equation at these 2 points, point 1 and point 2, we will have this equation. Now as the point Z1 and Z2, point P1 and point 2 are at the same height, hence we can say that Z1 and Z2 are the same. Hence we can neglect this from this equation. Now the velocity at point 2, V2 is also 0. Hence this V2 square upon 2g will also get nullified. Hence this P1 upon rho g, it is the head at point 1. At point 1 the head, pressure head due to the liquid level is equal to this P1 upon rho g is equal to capital H according to hydrostatic law. So P is equal to, according to this equation, P is equal to P1 is equal to rho GH according to this equation. Now similarly at point 2, this same static head, this same pressure head is equal to this P is equal to rho G multiplied by, here total height is small h plus capital H, means total pressure at this point is this. Okay, hence if we substitute these two values into the equation, we will get this H plus V1 square upon 2g is equal to small h plus capital H. This capital H on both sides will get cancelled. Then we will get the equation H is equal to V1 square upon 2g. If we simplify this equation for V1, then V1 is equal to root of 2gh. And obviously this V1 is the theoretical velocity at point 1. So we can measure the theoretical velocity at point 1 as root of 2gh. But the actual velocity, we have to multiply it by coefficient of the Pitot tube. So whatever the coefficient of the Pitot tube CV is, we have to multiply it to the theoretical velocity. We will get the actual velocity at that point. Hence the actual velocity at any point in a fluid can be measured by the Pitot tube by the equation V is equal to CV multiplied by root of 2gh.